Okay guys, so let's continue and further introduce new features for the network from our previous video. So what we are going to do now is to configure a BGP which run under the hood of the IPsec Tunnel, and we have to define a network for this. I already choose one. 9. Where is that? 169.168.10.0.30. This will be the network. The assignment on the left side, we always have the lower IP address, and on the right side we have the higher IP address. So in this case here we're gonna have .1 and .2 on the right. So let's first, now to enable BGP we have to first configure the interface, the tunnel interface with an IP. So 168.168. This was the range, if I'm not mistaken. Let's check once again. 169.168.1/30 is going to be. I'm gonna map a low ping management profile to this interface so I can try to verify connectivity once the tunnel is established. So the next thing, we have to go on the virtual router. For BGP we have to enable it, we have to give it a router ID. I'm gonna use the same one which I use for the tunnel. The IS number I'm gonna give is this one. And what else do we have here? Again, just to mention that we are targeting the simplest possible config, just for initially establish the BGP session. Then we can further complicate if there is a use case to do so, but now let's again focus on simplicity. So peer group, we have to define a peer group, and for peer group, right side power and right side power. There, the IS number, actually that's a question that is part of the design question when you are connecting to BGP devices. Part of the design is to determine whether the devices will communicate with iBGP or eBGP. So if you choose to run the same autonomous system, this means iBGP. But now in my case, I'm gonna use different autonomous system number for the remote device. I'm gonna terminate the BGP service on the tunnel interface. I'm gonna explicitly suggest the IP address, and here I have to point the PR address. Connection option, advanced, we don't need this. Okay, so I guess this should be fine. Okay, I'm not gonna map any import or export rules for now. What networks will be actually redistributed into the BGP or advertised via the BGP, there should be tabs somewhere to determine that. And redistribution rules. Enter subnet or create distribution profile first. Okay, so here I guess this is the place where I'm defining a prefix to advertise. So I'm gonna configure my local network here. And I'm not gonna modify any of the default parameters like metric, origin, met, local preference of or stuff like that. So I guess this should be enough for this device to advertise the prefix. Okay, and now we have output suggesting that our configuration is not complete. So peer group is already in use. Peer group is invalid. What do you mean peer group is invalid? What is already in use? That's strange. Type eBGP PR autonomous system. That's really kind of a strange. Peer group, right side power. Ah, this may be because of the name. Right side power peer, let's say. Okay, you gonna like it? Yeah. So now I'm committing the changes, and to make sure that my configuration is complete, I have to verify if the device is trying to establish a BGP session by sending connection requests to the BGP port. But first, for this to happen, I think we have to create explicit firewall rule to allow this. So first, let's just wait and confirm the suggestion. Okay, task is ready. So if we jump onto the traffic log and start to refresh, I'm expecting to see some traffic initiated from tunnel, but will that be the case? Because we have intrazone rule, which is supposed to allow the connection, but it isn't logging the sessions. So I'm gonna create intrazone rule, explicit intrazone rule, where I'm saying from a VPN, or maybe not from the VPN, it will be from any to any. I'm gonna lock everything. So this is explicit rule which allow connection, but the difference with the default rule is that this rule is logging the traffic. So I'm committing the changes now. There are also other methods, not traffic log, to determine if the device is already trying to establish a connection, and maybe we can even try that. If I set a capture with a destination address of the remote peer, 168.10.2 is the remote peer. Not using source address. Why you are suggesting me so? No, I don't want to set source address. Okay, just destination as a filter. Now we have to set different stages like firewall stage, FW, and maybe we can set a block drop stage so that we are sure if the traffic is okay. We already have something in the firewall stage. So if I open the capture, you see this is the BGP port, and it is now going through the firewall. So this device, actually The capture confirmed that this device is currently trying to establish a BGP session in... Yeah, here you can see from my explicit intrazone rule which I created, now we have logs for this connection. Okay, with that we are sure that the configuration on the left side PAO is complete, so we now jump on the right side PAO and proceed with the same config BGP. First things first, set an IP address for the tunnel. 169.168.10.2/30 map management profile to the interface, go into the virtual router BGP section, enable it, give it a ID, give it an AS number, configure a peer group, select an interface for BGP termination, select the peer, and now create the advertisement rule for the DC network, and I hope this should be enough. By the way, before establishing the BGP connection, I want to jump into the first device which I already configured and check what is the current BGP status. So give me a minute. If we run show routing protocol BGP summary, we're gonna see that the status for the BGP is connect. So connect means that the BGP session is trying to establish, but there is no success. And now I'm committing the changes on my right side PAO, and of course I'm gonna set a capture to make sure that the sessions to the peer or maybe I can even, yeah, okay, I can do it in that way. We have a filter, we have a stage, I'm gonna delete my old captures and I'm gonna run. Check if the commit is completed. Refresh a couple of times. And now we have lock on the firewall stage. So let's see what this lock is doing. BGP keep alive. Oh, we have even an acknowledgement, so that's positive sign. So let's recheck the BGP status from the left side PAO. And now what do we see? BGP session established. So that's a good sign. That's definitely a good sign. And now let's check if we have prefix advertisement. Show routing protocol BGP rip out. And here we can see that we are advertising this prefix to the peer. To make sure that this advertisement is working, I have to remove my static routes. Because if I jump onto the right side PAO, there will be a route for the remote network for sure, but it will be the static one. Show routing route. So the remote network is, where is the remote network? This is the remote network, and the static is the active route in the routing table is the static one. If we check show routing protocol BGP, not rip out but local rip, we can see that we are receiving the advertisement, but we cannot install it into the routing table because there is a route with lower distance, the same route with lower distance from the statics. So I'm gonna delete this one. I'm gonna commit. And now let's give it some time to complete the commit. And once this is done, we will check again the routing table to see if there will be a change to this entry. Okay, commit completed, so we check show routing route, and now that's an interesting, because we are not for some reason installing the prefix into the route table. And if I jump onto the client side and if I try to generate packet for the remote network, this is not going to work, of course, because a routing domain is not yet set. And we have to identify the reason why this device is not installing the prefix into the routing table. And if we check the default BGP config, I think this option here, install route, is the key. So if I now try to commit again with this option set, then the operating system will allow the BGP to inject the routes into the active routing table. Let's see. Okay, here it is. It pop up. Previously it wasn't there, now it is. And let's see what is happening with the ping. Okay, now we have connectivity. So that's it for today's video.